Okay, so now we do examples. Compute the contour around 0 of of this function. Okay, so what is this? So yeah, we can use the Cauchy integral formula. So note this is of the form f of z over z minus z naught, where z naught is inside, the contour. So let's see why. So this is 0, this is 3, and 2y is over here. So minus 2y, which is z naught, is inside. Okay. All right. So let's use Cauchy integral formula. So we have this f, and then we have minus 2y. Okay. So yeah, so we have 2 pi I times f of minus 2i. That's the Cauchy integral formula. Okay, so let's evaluate. So it's z squared minus 3z plus 4i. Yeah, so if you do the calculation, you get 20 pi plus I 8 pi. Okay, so that's the answer. That's it. All right. That was easy, right? No need for, Cauchy-Goursat or parametrization. We just followed the formula, and that was it. Okay. Compute the following. I think this is one of the textbook exercises. Okay, so what is that? Okay, this is a trick question. So first, let's find the contour. This is center at 2i, and it's this circle. It hits 0, and it goes up like this, up to 4i. Okay, what are the poles? So this is of the form z minus I pi times z plus I pi. Okay, so so the I plus minus I pi are the poles. But recall, this is what? This is 3, 14, da, da, da. So in the picture, where am I? Yeah. So one guy is down here. So minus I pi, and the other guy is over here, I pi. So only one pole is inside the contour, C minus 2I less than 2. Okay, all right. So let's use our formula. So sine z, C minus I pi, the square root, sorry. So yeah, still that's a negative number, so it would be, yeah, let me make it. Yeah, so we have this, and then, wait, was it pi squared? Sorry, there is no square. I'm sorry. I confused myself. I apologize. Okay. Okay, so I pi and plus I pi. All right, and the contour. Yeah, so this guy here is f of z because it's analytic inside C. So by the Cauchy integral formula, we have 2 pi I times f of, what is it, I pi. So sine of z over z plus I pi evaluated at c equal to I pi. So we have sine of I pi and 2 I pi. So we just have sine of I pi. And that's the answer. Okay. So this was a bit tricky because you had to, you had to factor. So that was tricky because you had to factor. So this is c squared plus pi squared. Okay. Okay, let's do another example. Compute the following guy, 2z plus 5, z squared minus 2z, okay, for the following two contours, for c equal to a half, and for c equal to z plus 1 equal to 2. Okay. Right. Again, you have to first find the poles. Always, that's your first step. So the contour is z a half, and this guy is z times z minus 2. So it has pole at 0 and 2 over here. Okay, so again, only one guy is inside. So we can just use Cauchy integral formula. So c minus 2 and then over z, and this guy will be f. Okay, so we have 2 pi I f of 0. I.e. 2z plus 5, z minus 5, evaluated at 0. So 5 over minus 5, so minus 2 pi I. Okay, so that's it. Yeah, that's it. Now the second contour. Okay. Again, you have to find the poles. So what is it? We are at minus 1, and it goes up to 1. So, sorry, a small correction. This is minus 1. Let me fix it. Minus. You'll see why I want minus 1. So yeah, the contour is centered at 1, and it has radius 2. So it goes up like this. Okay, so why do I pick this? Because now 0 and 2 are both inside. Okay, so Cauchy integral formula doesn't apply, does not apply. So please be careful. All right. So what's the trick? Now we do partial fractions. By partial fractions, we have the following: minus a half 2z plus 5 over z, and a half. Okay. So now we can do Cauchy integral formula. So we have 2 of them. Now this is perfect. So f, this is f. Yes, 2 pi I times f at 0 and 2 pi I f at 2. So this is Cauchy integral formula. Okay, so if you evaluate this, yeah, you get 4 pi I. Okay, so here we mean 2z plus 5 at z equals 0, and 2z plus 5 at z equals 2. Okay, good.